All right, welcome. Today, we're going to pull back the curtain on the secret chemistry that, believe it or not, connects just about everything in our lives. We're talking from the food on your plate to the soap in your shower. It's this invisible force that's just shaping our entire world. So let's dive in.
So let me start by asking you a question. What do French fries, soap, and your own body have in common? I know, it sounds like the beginning of a really weird joke, right? I mean, on the surface, what could a crispy snack, a bar of soap, and, well, you possibly share? Turns out, they all share a fundamental secret ingredient.
And that secret ingredient is carbon. Yep, carbon. This one incredible element is the absolute superstar of what's called organic chemistry. It's the foundation, the literal backbone for millions of compounds that make life and so much more possible.
So all this carbon-based stuff, it all falls under this one fascinating field, organic chemistry. So let's actually break down what that really means.
Okay, so here's the textbook definition. But what I love about it is its simplicity. See, organic chemistry isn't just something that happens in a lab with bubbling beakers and white coats. No, it is happening all around us all the time, every single day. It's the science of you in pretty much everything you touch.
And to really get a feel for this, let's bring it into the most familiar lab of all, your kitchen. I mean, this is where organic chemistry gets really, really real. And sometimes, yeah, a little teary.
We have all been there. You're just trying to chop up some veggies for dinner, and next thing you know, you're weeping over an onion. It's not you, I promise. It's chemistry. A straight-up chemical reaction happening right there on your cutting board.
Okay, so here's the play-by-play. When you slice into that onion, you're literally breaking open its cell walls. That releases a gas into the air. That gas floats up, it mixes with the natural moisture in your eyes, and boom, it forms a very mild sulfuric acid. Your tears are just your body's natural defense system, trying to wash that irritant away. Kinda cool, right?
And speaking of acids, that little onion reaction brings us to two huge categories in household chemistry, acids and bases. You know acids. They have that sour, puckery taste, like a lemon. And bases, oh, you definitely know bases. Just think about how slippery a wet bar of soap feels. That slippery feeling is a classic property of a base.
Okay, so we've seen these big, everyday reactions. But to understand how they really work, we have to zoom in, way, way in, down to the level of the tiny little building blocks that make up everything. Molecule.
You know, I just love this idea from the source material because it shows how beautifully simple science can be. To actually picture how atoms connect to form molecules, you can literally use something as simple as gumdrops and toothpicks. And this is especially helpful for carbon, because carbon has this unique superpower of linking up with other atoms to form these long, complex, amazing chains.
Now, to really unlock the mysteries we've been talking about, you have to get this one key concept. It's called polarity. Basically, some molecules are like tiny little magnets. They have a positive end and a negative end. And this happens simply because the electrons inside the molecule aren't being shared evenly between the atoms. And the poster child, the most famous polar molecule on the planet is water, H2O. The oxygen atom in water is a little greedy. It pulls the electrons closer to it. That makes its side slightly negative, and it leaves the two hydrogen atoms slightly positive. And believe it or not, this simple fact is the key to solving a classic kitchen problem.
So now, let's take what we just learned about polarity and apply it to something we do all the time, trying to wash away grease.
It's one of the most frustrating things, right? You've got a greasy pan, you run it under the faucet, and nothing. The water just beads up and rolls off, and the grease just sits there, kind of laughing at you. So why? Well, the answer is all about polarity. It all comes down to a super simple rule in chemistry. Like dissolves like. Polar water molecules love to hang out with other polar molecules. But grease and oil, they're nonpolar. They don't have those charged ends. So what happens? The polar water and the nonpolar oil, they just completely ignore each other.
But this is where soap comes in. Soap is the brilliant chemical peacekeeper here. You can think of a soap molecule as a kind of double agent. It's got a hydrophilic, or water-loving head that's polar, just like water. But it's also got a long, hydrophobic, or water-fearing, tail that's nonpolar, just like oil.
So here's the magic. Those nonpolar tails dive into the blob of grease, grabbing onto it from all sides. This forms a tiny little sphere, with all the polar, water-loving heads facing outward towards the water. So the soap has essentially gift-wrapped the grease in a water-soluble package, allowing the water to just grab the whole thing and wash it right down the drain. So after all of this, you might be thinking a little differently about your daily routine. And honestly, you should. Because whether you realize it or not, you've basically been a practicing chemist your entire life. So let's just quickly recap what we've covered. We've seen that carbon is this incredible element connecting our whole world. We've learned that everyday kitchen chores are actually pretty complex chemical reactions. We figured out why oil and water just don't mix, and we uncovered the secret of how soap works its magic.
So, the next time you chop an onion and start to tear up, or wash a greasy pan, just remember, you are surrounded by this incredible, invisible world of chemical reactions. You are putting the principles of organic chemistry into practice every single day.
The world really is a laboratory. From the rust on a bicycle to the way an apple turns brown, chemistry is absolutely everywhere, just waiting to be understood. So now that you can see the hidden chemistry, what will you discover next?